So, in the previous lecture, I told you that I will be discussing three types of linear programming problem using graphical method. Those three problems were maximization of objective function subjected to two constraint equations. The second problem was maximization of minimization of objective function subjected to two constraint equations, and the last one was maximization of objective function subjected to three constraint equations. So among these three linear programming problems, the first one I already discussed how to solve it using the graphical method. In this video lecture, I will be telling you how to solve the second problem, that is minimization of objective function subjected to two constraint equations using graphical method. So yes, this is the question that I have to solve, that is minimization of objective function, and here there are two constraint equations. They are x1 plus x2 greater than or equal to 8, and the second constraint equation is 6x1 plus x2 greater than or equal to 12. Now moving ahead, first I need to take the first constraint equation, that is inequality constraint. First I have to take the inequality constant. I will convert that inequality constant into the equation form, and then I have to find the set of points for x1 and x2. We'll draw a line connecting those points, and then we'll find the feasible region, as we have done in the previous problem, same with little change. So I will be taking the first constraint inequality constant equation, that is x1 plus x2 greater than or equal to 8. I will be converting this inequality constant equation into the equation form, that is x1 plus x2 is equal to 8. Now I have to find this is the equation of a line. Now I need to find the line on the graph. So for plotting that line on the graph, I need to find the points x1 and x2, and for that the technique is, first I will be putting x1 is equal to 0 in the equation 1, and then for that I will be finding x2. So here after putting x1 is equal to 0, I got x2 is equal to 8 after solving the equation. Next, again for finding the second set of point, I will make x2 is equal to 0 and will put that in the equation number 1, and then I have to find x1. So after putting x2 is equal to 0, I found x1 is equal to 8 from the equation number 1. So I got two set of points where x1 is equal to 0 and x2 is equal to 8, and x1 is equal to 8 and x2 is equal to 0. So in the next slide, I have shown the graph where x-axis representing the x1 decision variable and y-axis representing the x2 decision variable. Now I will be plotting these points, that is x1 and x2 set of points on this graph. That is, what was my x1 and x2 set of points? 0, 8 and 8, 0. So x1 is your 0, 8 and x2, again I am repeating, first set of point was x1 is equal to 0 and x2 is equal to 8, and the second set of point was x1 is equal to 8 and x2 is equal to 0. So I will connect these 2 points and I will get the line for that equation, that is x1 plus x2 is equal to 8 is the line shown here. Next step is, again I will be taking the second inequality constraint and will convert it into equation form. So the second inequality constant given in the question is 6x1 plus x2 greater than or equal to 12. So I have to convert this inequality constant into the equation form. The equation form is 6x1 plus x2 is equal to 12, and I have marked this as equation number 2. Now again, this is the equation of a line and I need to plot that line on the graph. For that I need to find the set of points for x1 and x2. And how will I be finding? First I will make x1 is equal to 0 and put it in the equation number 2, and for that I will find x2, and again I will put x2 is equal to 0 in the equation number 2 and I will find x1. So after putting x1 is equal to 0 in the equation 2, after solving the equation, I got x2 is equal to 12, and then I have put x2 is equal to 0 in the equation number 2, and after solving I found x1 is equal to 2. So the set of points are for x1 is equal to 0, x2 is equal to 12, and for x1 is equal to 2, x2 is equal to 0. These are the set of points. Now I will be plotting this set of points on the graph, and I will be joining these points to get the line for the equation 6x1 plus x2 is equal to 12. So finally I have got two lines that I've plotted two lines of the two constraint equations on the graph. The next step is to find the feasible region. Now to find the feasible region, I have to see whether the shaded area is above the line or below the line. So how will I get this thing? First, taking the first constraint equation. First I will be taking the first constraint equation, and for that constraint equation I need to put x1 and x2 is equal to 0, 0. If the constraint equation gets satisfied, then the shaded area will contain that part of the line, that part of the area which will contain x1 and x2 is equal to 0, 0. For example, here the constant equation, first constant equation is x1 plus x2 is greater than or equal to 8, and the line corresponding to this equation is shown here, joining the points 0, 8 and 8, 0, and I have marked this line as 1. So this is the line for the first constant equation. The next step is I will be putting 0, 0 in this inequality constant, that is x1 is equal to 0 and x2 is equal to 0, and I have got 0 which is greater than or equal to 8. That is, after putting 0, 0 in the x1 and x2 in the inequality constant, it is not satisfied. That's why the area above the line is the area that is satisfying the inequality constraint. Now for finding the area or the feasible area for the second inequality constant, again what I have to do, I have to take the inequality constant equation, that is 6x1 plus x2 greater than or equal to 12. First I have to put x1 and x2 is equal to 0, 0. So after putting x1 and x2 is equal to 0, 0, I got 0, but as per the inequality constant, 0 is not greater than or equal to 12. So after putting 0, 0 in the place of x1 and x2 in the second inequality constant is also not satisfying this inequality constraint. So means the feasible area is the area above the line marked as 2, above the line which will not contain the points x1 and x2 to be 0, 0. Now the next step is, as I have found here, the shaded area will be in case of both the lines will be above the line, that is not that area which is not containing x1 and x2 to be 0, 0. Now next point is I have to mark the overlapping area of both the lines. So overlapping area has been marked through the very light dashed lines, and I have represented it, I have named it as feasible region. So there are three corners of this feasible region which I have shown here as A, then this is the point B and the point C. So there are three corner points for this feasible region. So next step is I need to find this corner points of the feasible region. So The first corner point, as I already know, is visible from the graph that I've plotted. The first corner point A is 80. The second corner point B is 0.8, 7.2 that I have obtained from both the line equations, because this B point is existing at the intersection of both the lines. The line equations, what are the line equations? I've already told you. The line equations here are x1 plus x2 is equal to 8, and the second line equation is 6x1 plus x2 is equal to 12. So from these two equations, after solving these two line equations simultaneously, I'll get the points x1 and x2, and which has been obtained to be 0.8 and 7.2. And the last corner point is C, that is equal to 0, 12. So these three are the corner points of the feasible region. The next step is I have to put all these three corner points in the objective function and find the value of the objective function. So the three corner points are 80, as I have told you, A is 80. Second corner point B is 0.8, 7.2. So here given B is 0.8 and 7.2, and the third corner point is 0, 12. As I've shown you, the third corner point C is 0 and 12. So putting all these points, corner points, in the objective function, that is by substituting the values of x1 and x2 from this set of corner points, I will obtain the objective function. So here we have obtained the objective function. For example, here in the question, the objective function is z is equal to 4x1 plus 6x2. So first, when I will be putting the first corner point in this objective function, first corner point is x1 is equal to 8 and x2 is equal to 0. So after substituting x1 is equal to 8 and x2 is equal to 0 in the objective function, I got the objective function to be 32. Similarly, the rest of the corner points, I will be substituting the values of x1 and x2 in the objective function, and the objective function that I obtained for B and C are 46.4 and 72. Now, since the question is of minimization type, means minimize the objective function, I need to check among all the three objective functions, among all the three values of objective function obtained, which is the minimum. So as can be seen, for the point A, the objective function is minimum, that is 32 among all the three. So this is my optimum solution. Therefore, the x1 is equal to 8. Therefore, for point A, that is x1 is equal to 8 and x2 is equal to 0 are the solution, are the decision variables that I have obtained after solving this linear programming problem. And the minimized, that is optimum objective function I got is equal to 32. So the third question, that is maximization of objective function subjected to three constant equations, I will discuss it in the next lecture. So I'm ending this class here. Thank you.